Welcome to the official Erdos podcast, where we spend our non-productive time talking about drilling tech and getting the latest insight from industry leaders on our show. I'm Ken Miller.
And I'm David Erdos.
And today our guest is Eli DenBesten. Eli is the Operations Geology Manager at Taprock Resources.
That is correct, yeah.
Perfect. All right, so David, I'm podcasting from my new messy home office. You're podcasting from your closet. That's why we can't see you today, right?
Yes, that wouldn't be a very good sight.
Do what now?
It would be very dark, not a very good video shot.
So my question though is it tidy? Because I've been to your house before, and your house is exceptionally and impressively tidy. So I have to know, like, is the closet tidy too, or do you just hide all the mess in the closet?
Some of the closets are tidy, some aren't.
Okay, so there are some parts of your home that are not tidy.
There are, unfortunately.
Okay, well, I'm still impressed. Most people like me, and like my own office isn't even tidy right now. So, but yeah, it's another COVID special podcast, broadcasting from our homes, right? And so I was hoping to say we could, get out of this mode, but it looks like cases are going up, and that's interesting. So anyway, so Eli, tell us about your journey in oil and gas so far.
Yeah, it's been kind of I would say from the geology side, pretty unorthodox. The path for a lot of geos, it seems to be, especially before kind of the 2014 crash, was go to undergrad, go to grad school, work in the office directly. And, I got out of undergrad and really was pretty sick of not making any money and being really poor, and moved out west and, just had the 4-year degree and kind of worked from the ground up to kind of make my way through the field, and then, eventually in the office. And, that's, I think, starting off in the field. I started off in the DJ Basin, geosteering and mud logging there right off the bat. I think getting that opportunity to start geosteering in the field initially was pretty huge, and a pretty big jump for me to be able to go from that point, have the rig experience, talk with DDs, talk with MWDs, and work on the rig for a while, to have that kind of hands-on experience to then transfer into an office setting and bring a lot of value there, even without having a master's degree. Now, some companies really want you to have a master's degree as a geologist. It's a pretty stiff competition generally to get jobs in the oil industry in geology, but kind of more and more, I've been working out of the office now for about 4 years, and it seems like the guys that we hire on and the people that seem to bring value, at least to the operations side, and this seems obvious to probably everybody else, but are the ones that have spent time in the field, a significant portion of time in the field, really working hands-on, and especially in, I think, fast basins where they're making target changes on the fly, they're talking with DDs, you have to watch real time constantly kind of as you're steering. Those are the guys that I see bring a lot more value to an operations program, which is that may be just me tooting my own horn. That was my path, obviously, but it putting in those years in the field and really getting to know how the rig works and just how to drill it well, I think has been really valuable. It's not I guess, like I said, not common, but the operations geology, specifically the role, it's really changed, and it continues to change, as we're really just doing this underground mining, right, and really trying to drill faster wells, and it's really starting to really become heavily data focused. So that's an aspect that software has really enabled kind of over the last few years. I guess that's kind of a longer answer to your question, but yeah, it's kind of my path, at least.
No, that's fantastic. It's funny, you're talking to David. I mean, David, I'd say your approach was very traditional with schooling, right? Mine was very non-traditional. So I think my path was much closer to Eli's. I think they both can be valuable. I think personally, I think that especially with the tuition rates, college has become way overvalued. Like, it's just getting out of control, right? Yeah. I don't even know what to save up for my children to go to college, who are 1 and 4 respectively right now, because I don't know what that cost is going to look like when he's 18 in 14 years. Like, that's just the rank. Linearly extrapolate that, and we're in trouble, right?
Yep.
But no, I mean, there's just so much to be said for practical experience. And one of the things that we try to do at Erdos Miller is, even software developers, anybody in the office who's building anything for directional, we try and get them to the rig at least once, right? So they can see what it's like and how tough it is, and how much is going on, and just the weight of these things. So, like, what's a million pounds, right? 1 million pounds is a lot, right?
Yeah.
So a couple of things really stood out to me there. I really want to ask you about. So how do you just start geosteering, right? Because you started off as a mud logger, right?
Yep.
And then you got into the, can I just say that you don't fit the stereotype of a mud logger?
What is that?
I don't know. You seem very normal.
Yeah, I think the fact that I guess I don't know how to answer that necessarily, but yeah.
Well, forgive me, but my experience in the industry was like, the first rig I went on, the rig breaks, the mud lugger's like, hey, you guys want to go do some LSD and jump in the river?
Yeah. So
we don't. No, we're okay.
I think I have a good answer for that. I mean, yeah, I'm still a rock nerd. I guess maybe kind of a little bit of a hippie as far as I just love to be outdoors. I live in Colorado. I love being in the mountains, but and that on that aspect, I really loved being on the rig for that. But I think really, it's kind of the cream has risen to the top. When I started in 2014, it was kind of similar to that, right? And with the LSD and the drugs you're talking about,
it was mostly a joke.
But I know, but what drug testing, even that, operators got more serious about it, because it's like, okay, we have to drop rigs, and so I think it's really allowed like the more professional guys and the more professional mud logging companies in general to rise to the top. So since I've been in it, I guess I haven't. It's not that traditional. View, but I mean, the guys that I have working on my rigs now are, they're PhDs. There's some of them, working on the field, which is, you're like, I think you should have my job, right? But it's really changed. I think that job in general has changed. As we've dropped down to we're just under 300 rigs now in the U.S. So I mean,
actually, we're just over 300.
Did we just hit over 300? Okay.
Yes.
Yeah, so we were down in like the 260s. But yeah.
Yeah, it was a little bit of a depressing thought to realize that the industry is about 10% of what it was when I started.
Yeah. Right. So and since I started, it's kind of just continually gone downhill, right? And everything's gotten more efficient. Costs have gone down, and that's really allowed. I think that's really made the good, true geologists to be on those rigs. Now, to be a mud logger, you have to have a geology degree, pretty much. Like, you don't get these guys that are just kind of deadbeats trying to just make a couple $100 a day working on the rig and just calling shale versus limestone, right? It's almost always college educated guys, and if not, really highly experienced, that have been in the industry for a long time, if they're still out there. So but yeah, starting out in the DJ, really, I think getting the opportunity to geosteer and mudlog right away, just like you asked, just starting, how did I get started? I got hired on by a small company, basically as a contractor, and they plopped me in front of the computer with SES, and they kind of went over it with me, and for a week kind of trained, worked side by side with a guy, and then they just kind of let me go and figure it out. It was a huge learning curve, right? And I think that that was a huge opportunity for me because a lot of times you have to start out mud logging, and then you have to go to a geosteering position, and then you eventually maybe get to work in the office, right? And working for a smaller operator or a smaller company for an operator was kind of how I was able to do that. But yeah, definitely put a lot of they put a lot of weight on me without really much experience, which is they probably shouldn't have done in hindsight.
Well, I had a similar experience. The best thing about small companies is, and this can be a blessing or a curse, but they'll almost always give you enough rope to hang yourself, right?
Yeah.
So, I have to imagine it's very difficult and just takes a lot of learning and thinking and trial and error to, build up a mental model that you really trust of what that underground geology looks like, right? Because that's what you have to do. We these holes are not big enough for anybody to go down there and just take a look or whatever else. And I've imagined that would be really cool if you could. You know, the GeoVader thing at the Houston Museum of Natural Science is actually really cool. I definitely suggest everybody check that out if you haven't seen the Weiss Energy Hall there. But maybe not during COVID. I'm not sure. I think they're open.
Yeah.
I think my wife just took her kids there a few weeks ago.
Okay.
But anyways, so talk to me about that process of like becoming confident enough of like understanding, you know, the underground geology enough as to advise the rig where to go, because that's where we get from. Mud logging in my mind is, and correct me if I'm wrong, it's more about categorization and observing and just classifying what we're seeing. And then when you jump into geosteering, it's when you're now comfortable enough with that mental model to now advise the rig as to where to go. Or is that too primitive of understanding?
No, well, I think they go hand in hand, and it really depends on the basin. So, you know, a place like the DJ Basin, everything is pretty, we in geology we'll call it layer cake, right? But it's, you know, really pretty consistent beds of deposition. So you can almost steer a well using samples in that instance where you start drilling out of the limier rock into maybe more of a marl. You'll see that in the samples. If you've come down, you can tell them to come back up, right? The DJ has a lot of faults, which is also something that, you know, that's where bringing in the mud logging data really helps you. And they really go hand in hand. That's how I steer in general. If you hit a fault and you drill into maybe a lower section, that section of rock probably has some sort of characteristics you can see in the mud log. Even if it's the same lithology, it maybe has certain fossils that weren't maybe up in this higher layer, that can tell you, oh, we actually faulted into this lower block. We need to go down to get back into our pay zone. So it's really not one or the other. I think looking at geosteering from only loading gamma ray into a software like SES or StarSteer is really just a very short-sighted way to look at the operation side in general, especially when you start looking at basins like I have experience in the Anadarko Basin, which is, we'd say, heterolithic, not consistent. And then when you start going over to the Delaware Basin as well, really inconsistent rocks. So it's really taking all of that data, looking at all your offset logs, and really coming up with an idea of what the depositional environment originally was, what is feasible geologically, what's feasible from a depositional standpoint, and then what's feasible structurally, and making that mental model in your mind using all of the data that you have from offset verticals and from the current well you're drilling, other offset laterals, in order to steer those wells, and constantly being in communication with your mud loggers on site to be able to identify those zones. Okay, we came up into a limestone. Does that limestone have the same characteristics as the line that we saw as we were landing the curve, or does it look different to you? Does it have specific attributes that you would say it is not the same limestone, right? Those are the kind of things that I think, these geosteering centers that a lot of mud logging companies have. I'm not saying that they're bad, but they really don't have the full picture of what's happening in order to make the decisions, at least in really technical basins, that they really need to, in my opinion.
What's missing?
Really what's missing is all the geologic modeling software and all the data that we have working for an operator. They are given, for the most part, they get the MWD data, the surveys from the rig, and
you're talking about like a geosteering office, that like a remote geosteering office that maybe a directional driller has set up.
Yeah.
Okay, so they might not have access to the original, what do you call it, the geophone data and all this kind of stuff, right?
Yeah, like if there's seismic, if there's everything's planned off of older vertical offsets usually, which we have logs run through, and that's kind of where we can design our targets and look at the depositional environment. And I think in a really continuous basin, I think those service companies do a good job, where we have that like heterogeneous like layer cake model, like I was talking, like the DJ I think is a good one, that you can do that in, and probably the Bakken. But the more complex basins, you have to kind of bring in, I think, more of a more of a wider perspective on it and really understand the geology of what's going on.
Okay,
That's
so
really
it sounds
interesting.
like they're. Oh, go ahead, Dave. Sorry.
I was going to say I've never heard of geosteering and mud logging working so closely together. When obviously I'm on the drilling technology side, so I'm pretty far removed from the geosteering and actual rig operations. But like, how similar are these different offset wells? If you're in a given basin, how much can you trust other wells that were maybe a couple miles away to reference and kind of base your geologic model off of?
Yeah, so it's always an analysis of the data quality, first of all, checking KBs, looking over the directional surveys, and then also sometimes looking at the mud logging company if we do have mud log data for that offset to see, okay, who logged this well? Do we trust what's going on here? Because there is some human error factor there, but you also have things like XRD, XRF, which are they don't have, it's a machine that tells you, so XRF tells you elemental composition of the rock, and then XRD tells you what the actual lithology is. So if you have that data, those are good hard points to be able to tell you this is what the rocks are looking like over here. Now, a lot of times with offset wells, the verticals, those are good. Those are our best data points. We use those gamma ray logs and any other logs if we have triple combo to correlate across the basin, or even just across in our local area in the sections. And we use those to see what's continuous and what's maybe pinching out. And that's kind of what we build our structure grids off of. But using offset laterals really gives us an idea. We can re-steer those, look at where they landed them, look at the gamma that they saw, see if it changed, and put that into our model before we drill our wells to see, does our model hold up or does it not? So really, that's where I'm saying, kind of looking at all that offset data, looking at any piece of data that you have, is huge. Even down to like, how did they steer this well? It had a big. They went down and then they went back up. Okay, our structure grids aren't showing that. Is that feasible that structure's doing that, or were they lost? Right. Those can be really good data points to tell you if they were cutting down section, if they were cutting up section. It's a lot of guessing. I would say geosteering is kind of to me, these decisions are always kind of a coin flip a lot of times. You have, it's kind of like a 51% this way and a 49% the other way. Usually, you want it to be higher than that. But sometimes it's really, sometimes you can get really lost in these basins, and you just have to really be able to pull in all that data and say, the most feasible option is that we are high and we need to go down, or low and we need to go up. And sometimes that's all that you can do. But relying on the mud logs it's one piece of that, but it's especially in hydrolithic basins, it's really huge to be able to know what the rocks actually look like down there, and be able to cross correlate that to what we're seeing in gamma, because they're related, right? I mean, shales, you're gonna have hot gamma, limestone,
Right.
sand, you're gonna have cold gamma, and if those aren't matching up, then you have something very wrong. And 20 API difference you can see that sometimes in a shale, that the difference in that shale, the mud logger can be able to tell, or you can't. So that's where the mud logging comes in, and having those gamma ray relogs, making sure that your tool is calibrated exactly the same, is huge. And I know it's nobody likes to relog, but that's why geologists always want to relog. It's like, if we drill back through the shale and it has an API that's 30 or 40 40 API hotter, then we really don't have a way to correlate that, right? And so then we're guessing the interpretation for the rest of that run.
Hey, Dave, do you want to tell him, or should I tell him that the gamma instruments are all really poorly calibrated?
I think you should tell him.
Yeah, I'm sure there's not a ton of faith in it, but
well, I mean, no, I just I don't want to betray my little section of the industry here, but I mean, directional instruments, magnetometers and accelerometers are extremely well calibrated and checked all the time between every single run and all this kind of stuff. And gamma ray just kind of is what it is, right? I mean, calibration is kind of people certainly do it, but it could certainly be done better. It's not done over temperature. It's one coefficient for the entire well. There's not like a directional. We actually apply a curve, right? For the accelerometers and magnetometers, we actually look at how the accelerometer mag changes over its temperature and come up with a polynomial fit for that calibration, right? Versus, gamma ray, it's one scalar, we just apply an API, scalar to it, and then we just assume that that's the same thing the whole time. And obviously, no, it's a nonlinear instrument. It's informed differently over temperature. Now, is that actually going to make a huge amount of difference to go in and calibrate them? Probably not, but it's always kind of been like a head scratcher for me as to why we calibrate the directional instruments so well and gamma instruments are done so haphazardly, right?
Yeah, it's a problem with our data sets for sure. And I mean, per well, you want it to be close, right? If you have that scale factor the same for your well, for one well, that's really what matters. For our basin-wide data sets, yeah, the calibrations are all over the place, and that's where you have to bring in, you bring in a petrophysicist to run normalizations on all those logs and really try to get all of the logs into one database, and then be able to kind of get them to where they're reading same API values. But really, when we're correlating a lot of the stuff, it's looking at the trends in the gamma ray versus the actual API values. Sometimes it can be actual API values if you look at all your logs and you say, okay, these all look pretty similar. The normalizations all look pretty good. But a lot of times you're looking at a finding upward sequence or a coarsening upward sequence to tell you kind of where those depositional, those prograding and retrograding sequences are happening, to be able to tie those, across multiple sections to figure out what your structure's doing. So,
no, that's fantastic. And I mean, it's really cool to hear that you guys normalize all that gamma data. And with gamma, that's really what it comes down to, is the trend, right? I mean, you can scale a trend up, scale it down, all this kind of stuff. But I mean, the signature is the signature, right? And that's probably why the absolute calibration of the instrument isn't that big of a deal, is because you're primarily looking for the trend. And then sounds like you guys have developed techniques to normalize the data anyways, right?
Yeah, we have. It's not the easiest thing in the world. I think being able to have kind of all these larger data sets live on just the computing power now makes it more, makes us able to be able to really normalize, thousands and thousands of wells. And that's not my specialty per se, but a good petrophysicist really is able to perform, to run those algorithms and write those algorithms to be able to do that.
We have a similar problem with shock and vibe measurements, because nobody's tool is going to give you the exact same number of G's as anybody else's tool, right? Because the shock and vibe data from the bit, if you think about it, it goes to the bit, goes to the motor, goes to the NWD, goes to the accelerometer of the NWD, and it's actually observed at the accelerometer on the NWD, right? And and everybody mounts those accelerometers differently on the board. The boards are mounted to the chassis differently. The chassis is mounted to the NWD better differently. The NWD is mounted to the collar differently. There's shock absorb designs, there's lockdown designs. I mean, trying to get everybody to register a 50G shock in the same way is a failing mission, right? But I've never seen two shock sensors from the same tool that didn't match the trends identically, right? Yeah. And so we really rely heavily on the trends there, right? So one of the things I picked up on is that you said that there's definitely basins that are what did you say, heteronormal?
So heterolithic or
right?
Homogeneous. Yeah. Heterolithic, right? Just means, just the deposition is not consistent. It's that you maybe have a debris flow coming in, then a shale deposition, and then sands are coming in this way, and then another debris flow. So you get kind of this weird, not perfectly, like I think a lot of people think of rocks maybe not this way, but just perfect, like you're stacking books on top of one another, right? And you're like, okay, here's the layer, we're trying to drill right in that one.
Well, that's how it gets explained every time, right? Nobody ever talks about the dips and the faults and whatever else. That's always afterthought.
Yeah, so I think the first, looking at it from like, okay, a book standpoint, or a layer cake is kind of what they call it. And then you start thinking, okay, what's happening structurally, right? Is it dipping? Which way is it dipping? And then, okay, do we have faults running through that? But then you start looking at what I like to call is depositional structure, right? So you would have maybe multiple sand lobes that are coming off into a basin that are kind of covered in these shales. So you have, it's kind of hard to not have a diagram to show it, but basically, your gamma signature is not going to be consistent, because you're going to have lobes kind of just like depositing on top of one another, and then like another shale, maybe a flood surface will come on top of that. So if you're trying to read the actual dips of those sand beds, you're going to get fooled every time, because they're not actually deposited in this perfect continuous package, right? In the Delaware Basin, if you're close to the Central Basin Platform, you have a lot of shale in the middle of the basin, and then those layers, as you get closer to the edge, you start having limestones come in, right? And so you have shale and sand, and then your sand actually starts turning in. These debris flows start replacing your sands, and you could be drilling a well over there, and your good sand or your good shale is all of a sudden replaced by a large, giant blocks of limestone that have caved off the Central Basin Platform and then been deposited there. So
that sounds extremely fun.
It's extremely fun. It's extremely difficult, and that's what makes the hydrolithic basins just way more difficult to geosteer in, right? And being able to, like before I was talking about, looking at those offsets, looking at stuff, if we're on the east side of the basin, looking at offsets to the east of our well is going to tell us, okay, was there a debris flow here? You can't always pick it up on the logs, but you can see increase in limestone in specific logs, and then you can see it decrease as you go to the west. Seismic is huge for that. If you have seismic, you can not necessarily pinpoint exactly where those debris flows are, but you can start to kind of see where those trends are. So that's another big aspect that kind of gets more into the more exploration side. But yeah, it's like I said, it's bringing all the data possible that we have to try to figure out the puzzle and figure out if we drilled into a giant block of limestone that was deposited there, or if we faulted into it, right?
Well, and that kind of reminds me a bit of like a failure analysis with NWD, right? And so, I mean, every extra bit of data you get when analyzing a failure just makes the possible range of conclusions and likelihood that you're going to come to the correct conclusion so much better, right? Because like if you just give me the memory, well, I mean, I can tell so much from the memory. It's really good, right? And I'll probably come to the correct conclusion, but I mean, you can have just a summary, you can have memory, you can have pictures of the tool, you can have access to the tool, all these kind of things. And if you have just a little bit of the data, you can come to a totally wrong conclusion that looks right based upon just having a little bit of data, right?
For sure, yeah.
And so, I mean, so the way what you're telling me is like there are basins that are super easy, like the DJ Basin, right? Not super easy, but relatively straightforward to geosteer.
The deposition, yes.
Yeah. And so then you have other basins. You said which basin was really tough?
Anadarko Basin generally,
Anadarko.
Drilling some of the sands there is pretty difficult. And then, the Delaware Basin, I would say. That's most of my experience, but yeah.
I know a group of guys that are really trying to automate this entire process, and they're trying to throw like AI and neural networks at geosteering and have those things make the decisions. And I can see the look on your face right now.
Yeah.
But it sounds like if they were to be successful, they probably want to start off and just focusing on the DJ Basin, right?
Yeah.
And focusing on trying to automate the more straightforward basins to geosteer in, and then stay the hell away from the Delaware and Anadarko, right?
Yeah, I think so. Yeah, for sure. You wanna go somewhere where that the gamma ray signature is going to be consistent throughout your entire section. And the DJ has a lot of structural complexity, but if you're writing up and down section, you can find a tie-in, right? So you might hit a fault, but that's still, you're going to be able to know essentially once you get a little bit more data exactly where you are. And there are assisted automated geosteering. StarSteer has a version of theirs. I think there's a couple other companies, like you said, trying to do it, and they do a good job in those basins that have consistent gamma ray packages where your deposition is extremely consistent. What you're going to look like. But yeah, when you start getting into more complex basins, how does that algorithm deal with well, now our gamma ray log looks completely different because we drilled into a debris flow, or the sand that we were drilling in originally is actually not even here anymore. That can happen. So yeah, that's where you still need to have there's a reason that we spend all our time mapping and trying to correlate these things. Is you still need to have a geologist to say what's feasible and understand the depositional environment in those cases. So yeah.
Well, I was just going to say, I think we're running a little short on time, but I do want to squeeze in one more question. We talked a little bit about the importance of all this data. What additional measurements or more dense measurements would make your life as a geosteer easier?
That is a good question. I think azimuthal gamma ray is a good tool. I haven't really used it very much. On the directional side, really, I think one of the biggest tools, honestly, is being able to use rotary steerable assemblies to a certain extent, and be able to kind of point that BHA where you want it to go. A lot of times you spend a lot of time undulating between survey points with a conventional assembly, and you really, I mean, you guys know this, as the farther you get out into your lateral, the more difficult it is to really get a true TVD reading on what that TVD actually is. And that is a huge error bar in our interpretations. And then if we're using those interpretations to make maps for future wells, that makes things much more difficult. Survey accuracy, I would honestly say, just in general, I think with a rotary steerable, you get a better idea of where you are the entire time. And I think, you probably have a better, that error gets smaller and smaller. But that's, for me, just looking at it from a mapping perspective and trying to like use the data to continue to model the basin. We have so much more horizontal data than we did before, and that can all be used, but we can't run a gyro down each one of these laterals, so being more accurate with that is I think a huge part of it. Right now I have an algorithm that I run that basically uses continuous inclination, which I think is massive. It wasn't when I first started working out in the DJ, they didn't have it, and then they started implementing it a little bit later. But running a continuous inc calculation between survey points to tell you where you are and kind of see those deviations and see how far away you've actually trended from where you think the wellbore is really, really huge. I think that's a part that a lot of geologists and geosteers overlook, and they don't really think about the actual accuracy of that data.
Yeah, that's one recent well, actually. We had continuous inclination included with the survey corrections versus without. There was a 28-foot TVD difference.
At TD?
Yeah.
Yeah. So, I mean, that's
a
huge difference, right? I mean, if you're trying to model a basin and it's pretty flat and you're actually 28 feet off, I mean, you go drill a well next to it and your zone's only 20 feet thick, you might be out of zone with that model. So
I can see in my head a specification for like a, cost-effective, simplistic, rugged, rotary steerable system that has continuous inclination and ASI-gamma sensors built right into it. And I think that's the tool that just, takes the market, honestly.
That would, yeah.
Yeah, I mean, it's just, and it's all very possible, right? Like the ASI-gamma packages are small enough and rugged enough, we can put them in there. They can be short hop back to the NABD for transmission, or you can build the NABD directly in. But I mean, I feel like, of all the possible measurements and all the possible things that you could ask for, that's like the AK-47 of drilling tools, right? That's like
for sure
your get her done, basic, this is just what I need and no more kind of specification, right?
Yeah, I would 100% agree. Yeah.
David, I got a couple more questions I just got to ask.
Yeah, go for it.
So I've always been told we operate, in the US a lot and then a little bit internationally, right? And internationally, these guys can't live without at least resistivity, if not triple combo, right? Mm-hmm. And so I've heard numerous explanations over the years as to why that is and why the US just mostly predominantly relies on gamma ray and all this kind of stuff. But I'd like to hear your perspective on that.
So I think, offshore stuff, they're probably dealing a lot more with conventional wells. If I'm thinking about this right, I don't have a ton of, or not offshore, I should say, but like overseas, they're drilling conventional reservoirs, right, where they're poking holes and anticlinal features and trying to look at the quality of the reservoir, and most of that is based off of seismic. So you at least want to have sonic logs to be able to tie your seismic to be able to kind of tell what those TVDs are going to be. In the US, I think really, it kind of comes from being cost effective a lot of times and not really. I mean, when we started geosteering, we were doing it with Excel, right? I mean, there wasn't these fancy programs like StarSteer, or even SCS was a huge jump in technology to be able to really model that and look at it. And I think it's really a cost thing. I think that we can get by without needing it. And I think that's ultimately why, especially especially just drilling these horizontal wells, your gamma ray can still tell you a lot. And really, if you have a triple combo, and we still do triple combos, we still cut core, that's still in our science budgets to do those things. It tells us about the quality of the reservoir, and we can tie those, high tier quality wells kind of across areas if we have them, and then we can correlate with our gamma ray between those, right? Having resistivity is huge for some of those correlations depending on the basin, but if it's a simplistic basin, you don't necessarily need the resistivity even. So yeah, I think it really comes out of like cutting costs, and really it's not always necessary if you are going to be drilling that horizontal. Either way, you can pick your pay zones off of your good triple combo logs, and then and extrapolate from there. So yeah, that's kind of, yeah.
Talk to me about big data with geosteering right now. You alluded to that earlier. What's geosteering like today with big data?
Yeah, so right now there's a big push to be able to connect really programs like Petra is kind of like traditionally what's been used to map and model, and these are projects that have an entire basin built on them with all the wells, all the logs, all the casing points, everything, and that's kind of where all the geologic mapping is done, and where all the prospects are looked at. The steering software really never talked with that data, and so you pull the data out of that large data set, put some of it into StarSteer or SCS, steer your wells, and then you have a screenshot of that. And then you're like, okay, we kind of know what we're looking at. That's okay. And then you were able to start exporting control points back into Petra to be able to do that mapping. It's gotten better and better now to where, programs like StarSteer, you can pull all of your data from that large database into StarSteer and actually map in that program. And so you can use all those control points along a wellbore. When I say control points, it would be, the formation tops that we saw when we were drilling that horizontal, and then kind of looking at the average dip and using that dip to create a new map. So that's like kind of the first aspect of it. Then, now we're able to actually export all the data from our steering projects for an entire basin, put that into a server where we can look at all of that data from the gamma ray and all the geologic stuff, right? All the mud logging data, the XRD, the XRF, like I mentioned, maybe mass spec data, gas data, but also bring in all of the drilling data that we get. So I'm constantly running MSC in my projects. I calculate my own MSC with a Python script, looking at collar RPM, looking at weight on bit, looking at, comparing all that to our ROP, exporting all that data from StarSteer, putting it into Spotfire, and looking at those different, looking at all that data and really analyzing how are these rocks drilling and where can we optimize, our pay zone or in our verticals where are we burning up bits. Look, we slowed down maybe our gallons per minute. Lowered our RPMs through this specific rock, and we actually saved a little bit of bit life there. We made it a little bit farther. Maybe we need to look into that more. So that's one aspect of it. Then you can also bring in your completions data, and you can link your production data to that, right? So now it's really becoming a operations geologist is really, you're not just geosteering anymore. Really, you're really running a lot of this analytics and going back to where we started at the beginning of the conversation, having experience in the field and understanding what's happening and really understanding what drilling is doing and what these parameters mean and being able to look at them is extremely helpful to be able to bring a drilling engineer in and show them a plot and say, this is what we're seeing on the geologic side, and show them maybe ROP heat maps or something that we can optimize our drilling. We can drill these faster, right? So much of what I'm doing is trying to figure out where can we drill faster that's still close to our pay zone or within our pay zone. And a rotary steerable tool, yeah.
Awesome. That is also awesome.
Like a rotary steerable tool, like you said, is the mecca of that. Just due to the ability to make those quick corrections and maybe keep it within a smaller pay zone. Even if our pay zone is 20, 30 feet thick, if you find a good shale in the middle of it that drills, extra 50 feet per hour, and you have azimuthal gamma ray with a rotary steerable, you can see where you're getting close to the bottom and just kind of continually just kind of work it up or work it down depending on where you're at in that zone. So making those tiny corrections.
You don't have these overshoots anymore with like a conventional assembly, right?
Exactly. Yeah. So,
which if you're a control systems nerd looks suspiciously like PID overshoot, right?
Yeah.
But I really picked up on the fact that you do a lot of Python. So do you actually write the Python code yourself for all the analysis and stuff like that?
Some of them I do, some of them I don't. There's, these programs have kind of built out scripts already, a lot of them, but I do modifications and write other ones to, calculate different log parameters that maybe I want to see. I can basically run calculations on any logs that I have that I can put into StarSteer from anything from Payson. Any of the parameters from the drilling, from the rig, and anything that the mud logger's given me, I can put them in and basically run calculations right in the program in Python. So yeah, I do. It's a mix of both. I'm definitely not a Python expert, but
well, that's the wonderful thing about Python is it is just such a fantastically easy to use programming language.
Yeah.
You don't have to be an expert to actually achieve something in the real world with Python, right? Like
exactly.
I really can't recommend learning Python enough to people. I mean, it is such a great way to get introduced into programming. And look, a lot of people are having a tough time in their career right now between, the oil price crash and COVID and everything. A lot of people looking for what they're going to do next and whatever else. You can add so much, value to what you can do in your career if you learn a little bit of programming. And Python is a fantastic place to start.
It really is.
I highly recommend it.
Yeah, and we just hired on a couple more operations geologists, and the biggest thing for us really was, do you at least understand these languages, and how are you with basically being able to manipulate this data and do a little bit of programming? And that's where this operations geologist role has gone from really nerding out on the geology to, you still have that, but we have massive data sets, tons of data that we can look at, and a lot of companies just sitting there. And so finding a way to really incorporate all that data from the drilling side all the way through to production, it's becoming more and more the role of the operations geologist. And that's what I think is really changing, and hiring on new guys. It's like, what type of skills, especially in programming or maybe SQL Server, or even being proficient in Spotfire, what sort of tools can you bring to the table that are going to help us optimize our ability to really digest all the data that we currently have and take it to the next step?
And the data is in new formats. It's no longer on paper printouts. It's in databases and Excel files and CSV files and SQLite files and whatever else. And there's 100,000 times more of it than there used to be. And there's so many positions anymore. Even as CEO of a tech company, I've been sitting here writing scripts in Python, right? To work with our receiver data systems, right? There's just so much of anyone's job anymore that's just pushing around data and analyzing it, that typically wouldn't. It's just a critical skill to have.
Yeah.
So I've got one last question and then we'll wrap her up. MWD, friend or foe?
Am I a friend of MWD's?
Well, are MWD's a friend or foe to you?
Yeah.
Getting your job done.
I like to be friendly with MWDs personally. I start to get when I worked in the field, I was friends with most of those guys that I worked with. If they were, it all depends on how much bad data you send me. If I tell you to correct something 4 times and every time you send it back the same, that's when I start getting mad. But no, I like MWDs. Definitely not a foe.
I'm just teasing as to whether I'm just curious as to whether or not that's typically a at distance relationship or a very close relationship.
Yeah,
that's kind of what I'm getting at.
Yeah, not as close. Being in the office now, definitely not as close. When I worked in the field, I was talking to the MWD a lot because half the time the DD's up sliding or is in the doghouse. So I spent a lot of time, obviously, hanging out with MWDs and
there was a funny statement from the NWD perspective I heard one time, which is, why the hell should I care about where we are if the geologist can't tell me where the hell we're supposed to be?
Yeah, that's fair. That is very fair. Yeah.
So very good. Well, Eli, this was fantastic. I really enjoyed our time here today.
Yeah. Thanks so much for having me on. It was really enjoyable. Yeah. Thanks.
All right, well, that's all the time we have for today. Thanks again, Eli, for joining us and for sharing us and giving some insight into geology and geosteering. Be sure to check out our podcast on iTunes, Spotify, and YouTube. Thanks for tuning into today's episode.